So in this lecture, we discuss how to trace the Rose curves. Rose curves are also the special type of polar curve. Suppose the equation of the Rose curves is given by r equal to a sine n theta or r equal to a cos n theta. For tracing the Rose curves, we take the following points. First point is symmetry. There are following symmetries. Of course, there are three types of symmetry in polar curve. So also here, the first symmetry is about the pole. Since the polar power of r is always 1, like that, because it is what is the format of Rose curve? It is either r equal to a sine n theta or r equal to a cos n theta. So the power of r is always 1. So Rose curve, right? So it is not symmetric about the pole. So Rose curve is always not symmetric about the pole. Second point, about the initial line theta equal to 0. If the equation to the curve remains unchanged by changing theta to minus theta, then the given curve is symmetric about the initial line theta equal to 0. For example, if r equal to a cos 2 theta. So here, if we replace theta by minus theta, the equation of the curve will not change. Therefore, this curve is symmetric about the initial line theta equal to 0. Similarly, the symmetric about the line perpendicular to the initial line through the pole, and which can be simply say that line theta equal to pi by 2. This can be checked in the two ways. The way number one, if the equation to the given curve remains unchanged by changing theta to minus theta and r to minus r, then the given curve is symmetric about the line theta equal to pi by 2. For example, r equal to a sine 2 theta. Now here if we replace r by minus r and theta by minus theta, so the equation will be what? What is this minus r, which is equal to sine of minus theta is minus sine theta. So minus a sine 2 theta, right? And now this minus minus will cancel and we have the same equation. Therefore, the given curve is symmetric about the line theta equal to pi by 2. Now, suppose this will not happen. This is not true. Then we have to check one more symmetric about the line theta equal to pi by 2, which can be uh, checked by replacing theta to pi minus theta. Then the given curve is symmetric about the line theta equal to pi by 2. For example, if we have r equal to a cos 2 theta, right? Here, if we check the first part, if we replace r by minus r and theta by minus theta, then the equation will be minus r a cos 2 theta. But if we replace theta by, if we replace theta by pi minus theta. So what is this? Cos 2 pi minus 2 theta. What is this? It is cos 2 pi minus 2 theta, and cos 2 pi minus theta is nothing but cos theta. So the equation of the curve will not change. So the this curve cos a cos 2 theta are equal to a cos 2 theta is also symmetric about the initial line theta equal to pi by, sorry, line theta equal to, not initial line, line theta equal to pi by 2. Right. So these are about the symmetry. Let me go ahead for the next point. Pole. For any value of, we know that for any value of theta, if r becomes 0, then we say that the curve passes through pole. So the this Rose curve always passes through pole because if we can get any value of theta for which r equal to 0. Now next thing is tangent at pole. So how to get the tangent at pole? Tangent at pole can be obtained by putting r equal to 0. So we have to just put r equal to 0. We are able to get the tangent at pole. Now, the very important point is about the loops over here. The Rose curve consists of n equal loops if n is odd and 2n equal loops if n is even. This is very important. Okay, what it means? For example, suppose we have given r equal to a cos 2 theta. What it means? Since the value of n is even, so we get the four loops we get. Suppose r equal to a sine 3 theta. So here the value of n is 3. So we get the same number of loops. So it is 3 loops. And if we have r equal to a sine 4 theta. So here again 4 is even. So we get the 2 into 4 means 8 loops, which is equal to 8 loops. So this is very important. While tracing the curve, we will see that how we are getting the different loops. For drawing the loops of r equal to a sine n theta, we divide each quadrant into n equal parts. First loop is drawn along theta equal to pi by 2 divided by n. If n is even, we draw loops in two sectors consecutively from theta equal to 0 to theta equal to 2 pi. So this is how, when we take the example, then we will discuss much more about this thing. If n is odd, we draw loops in two sectors alternatively, keeping two sectors between the loops vacant. This loop is very important, right? Where we have to draw the loop. That's why the drawing the tracing the rose curve is very simple as comparing to polar curve. For drawing the loops of r equal to a cos n theta, we divide each quadrant into n equal parts. First loop is drawn along theta equal to 0. If n is even, we draw loops in two sectors consecutively from theta equal to 0 to theta equal to 2 pi. And if n is odd, we draw loops in two sectors alternatively, keeping two sectors between the loops vacant. Angle between the radius vector and the tangent. So with the formula tan phi is equal to r d theta dr, we can find phi and also the points where phi which is equal to 0 or infinity. Table values. We prepare the table values of theta and r and observe how r varies as theta increases from 0 to 2 pi. Asymptotes, we will try to find the asymptotes if possible, but most of the time we won't get the asymptotes in this case. And the reason of absence of the curve. Now, for the rose curve, the maximum numerical values of r is either a, and hence the entire curve will lie within a circle of radius a. Right? So now whole rose curve will lie only within a circle of radius a. Since sine theta and cos theta both are periodic functions of period 2 pi, so the value of theta from 0 to 2 pi should only be considered. Right? Because if we take the more than 2 pi, and it doesn't mean anything, because that will be again repeating the same thing. R equal to minus a means radial distance to be taken in the opposite direction. If sometime we get r equal to minus a, what it means? Suppose this is we are getting for theta equal to pi by 2, r equal to minus a. What it means? It means that we consider about this point. This point will be, this is r equal to a, r equal to a, the opposite direction. Since the shape of the curves are like rows, so these curves are known as rose curves. So this is all about how to trace the rose curve. In the next lecture, we trace the particular rose curve. Thank you.